So the next thing we can learn about the unit circle is sine, cosine, and tangent. So the sine is equal to the y values on the unit circle, and cosine is equal to the x values on the unit circle, and tan is equal to sine over cosine. So that means its tangent is equal to the y over x values of the unit circle. So if we were to say that if we were to take this angle 0 degrees, that means sine would be 0 and cosine would be 1, because this is 1 comma 0, so it's x equals 1 and y equals 0. And then tangent would be sine over cosine, so we take 0 over 1, so then that would just be 0 over 1, which is 0. So that's how you can use, or that's just explaining what tan is. So it's just sine over cosine. So you can just think about it as the y value over the x value, and that's equal to the tan. So the next thing we can do with the unit circle is figuring out the Pythagorean identities. So with Pythagorean identities, there's 3 common ones that people use. So the first one I think is the most common. It is sine squared x plus cosine squared x equals 1. So this is shown because the formula for the unit circle is also x squared plus y squared equals 1. And if you remember back, we know that cosine is x and sine is y, so it's almost the same thing as x squared plus y squared equals 1. And then the next one we can do is 1 plus tan squared equals secant, 1 tan squared x secant squared x. So now the next one, as I was saying, there's 3. So the next one we can do, is 1 plus cotangent squared x equals cosecant squared x. And if we were to use these identities in the unit circle, let's say if we use this one, we could say like, we could just say sine, let's say if we take the angle 45, sine squared of 45 degrees plus the cosine squared of 45 degrees equals 1. So that means if you take the sine squared, which is this squared, plus the cosine squared, which is this squared, this is just going to equal 1. Okay, so now let's solve some problems using the unit circle. So the first one asks for sine of 60. 60 degrees right there. Okay, so since it asks for the sine of 60 degrees, we have to go and whenever it has positive degrees, that means we go counterclockwise along the unit circle instead of clockwise. That's for when it becomes negative, and we'll get to that. So we go to 60 degrees, and if you remember, sine is the y value. So the sine of 60 is going to equal the y value of 60 degrees, which is, in this case, root 3 over 2. So that's the answer to that. Okay, and then the next one, we have cosine of 210 degrees. So we go counterclockwise along the unit circle 210 degrees all the way, which is right here. And that's cosine, which is the x value. So it's negative root 3 over 2. So we can just say this is cosine 210 equals negative root 3 over 2. Okay, and now this one, that's 4 pi over 3. Okay, so the next one is 3 sine 4 pi over 3. Now if you notice, this isn't in degrees anymore. This is in radians. So we have to go and see where on the unit circle it shows 4 pi over 3. So if we just go along and we see that this is 4 pi over 3, which is the same thing as 240 degrees. And since it's asking for the sine, which is the y, we can just take the y value, which is negative root 3 over 2. So sine of 4 pi over 3 equals negative root 3 over 2. Let me just circle the answer. Okay. Now, tangent of 11 pi over 6. Now, this is different. They're not asking for sine and cosine anymore. And if you remember from the beginning, tan x equals sine x over cosine x. So what we have to do is see where 11 pi over 6 is on the unit circle, which is right here, which is also 330 degrees. So instead of just taking one of the answers, we can't do that yet because since it asks for sine, we have to divide the two numbers. So we take negative 1 over 2 and then divide it by the cosine of 11 pi over 6, which is root 3 over 2. And then we can just bring this to the top and bring this to the bottom. So this is going to equal negative 2 over 2 root 3. You can rationalize the denominator, but if you want to, but that's just going to be the answer. Okay? And now, this is a little different as well because instead of going counterclockwise, we go, we go clockwise this time. So, since this says sine of negative pi over 3, one way I like to do it is see where pi over 3 is when you go counterclockwise, which is 60 degrees. So if you go negative pi over 3, you go clockwise 60 degrees as well. So this is 30, this is 45, and this is 60. And you can tell because 360 minus 60 is also 300. So this is also the same as sine of 300 degrees, which is just going to be negative root 3 over 2. So we can say that sine negative pi over 3 is negative root 3 over 2. Okay, so the next and the last question is tangent of negative 5 pi over 4. So this has everything. This has tangent and a negative and radians. So let's think about it. First, we see that this is negative 5 pi over 4. So we're going to be going counterclockwise. Next, we see that it's in radians instead of degrees. So we look at these numbers with pi. And then last, we see that it's tan, which is sine over cosine. So first, let's see where 5 pi over 4 is when you go normally without the negative. So that's going to be all the way here. So 225 degrees, which is also half of the unit circle, 180, plus 45 degrees. So if we go clockwise, we go 180 degrees and then plus 45 degrees, so 1, 2, and we end up at 135 degrees. So this is also the same as tan of 135 degrees. And now this makes it a little simpler. So we have degrees and tan now. So all we have to do is take the y value and divide it by the x value. So let's do that. And then you can see that it's just root 2 over 2 divided by negative root 2 over 2. And if you know that anything divided by itself is 1, but in this case there's a negative sign, so this is just going to be negative 1.